A good morning to all. I hope all to be doing good and to also be doing the most with regards to the mathematics. So now remember that the only way to improve would be to be consistent with your work. So that would be to practice. So now, gents, I want us to continue with the quadratic, and we will be looking at the quadratic turning point form. So now the turning point form itself is derived from the quadratic general form. So remember that the general form, which I will highlight just now, so that in itself would be the general form. So that would be the form that we are all used to. So now the general form can be converted to the quadratic turning point form. So we'll go through that a bit later on. So now this in itself, I'll just maybe highlight it with the blue. So now this in itself would be the quadratic turning point form. The reason why it's named such would be because of the P as well as the Q. So the turning point, which I will just abbreviate as TP. So the turning point, TP, would read as P is to Q, which would be just these numbers over here. So now getting your quadratic general form into the turning point form helps with the turning point itself. So you are able to quickly pick up on the turning point. So now remember that to get the quadratic, to get the turning point for the quadratic general form, you would need to make use of the x, which equals negative b divided by 2a. So that would be how you would make use of this equation to find the x coordinate of the turning point. To find the y coordinate, which would be the q, you would then need to substitute in the x coordinate into the original equation. With the turning point form, the P and the Q, which are the turning points, are already given. So you don't necessarily have to make use of the of this equation over here. So you don't have to make use of that equation for this portion, or rather for the P and the Q. So now, gents, I want us to also just move on to the A. So remember that the A is the coefficient of x squared. So this A over here matters. So now how the A matters, I'll just maybe move on to the next page to explain it. So now how the A matters, remember that if A is greater than 0, so that would be a positive A. If A is greater than 0, you will get a concave up. So that's a happy face, or rather a smile, if you may. So now what this means is that the turning point itself, which would be P is to Q, would be the minimum, or rather the y value, the Q, would be the minimum. So that would be a minimum value. So no value would be smaller than the Q. So that's if A is greater than 0, a happy face. If A is less than 0, so that would be if A is negative, you get the concave down. So that would be the concave down over there. So now this in itself would be a sad face, and it would then make the y coordinate of the turning point a maximum. So Q would be a maximum. So now what this means, or the implications of it, is that if you had to write out your range, So remember that the range would be the smallest y value to the biggest y value. Also just note that the this in itself goes to positive infinity from the turning point Q, and this in itself goes to negative infinity from the turning point, or rather from the negative infinity to the turning point, since Q is a maximum. So now you can then write your range. So remember again, the range would be the lowest y value to the biggest y value. For a is greater than 0, so that's a positive a, you can then write your range as the smallest value, which is the q, the minimum. So that would be included, square bracket. So that would be the q is to the positive infinity, which would be the biggest y value. And you can then just have that closed off with a curved bracket, since the infinity is not an actual number, so you cannot include it. So now for the a is less than 0, so that would be a negative a. We would then move from the smallest value to the biggest value. So now the range would then read as, so that would be the range over there, the smallest value, which is the negative infinity, all the way to the q, which would be the maximum value. Actually, you would need to include the q. So that would be the square bracket over there. So now remember that the p itself, so that would be the p. The p would be a the p in itself would be the axis of symmetry. So that would be you cutting the graph in half. That would be the equation of the axis of symmetry. So the equation of the axis of symmetry would be x equals p, which is the x coordinate of the turning point. So now I want us to just be able to convert. So that would be able to convert from the quadratic general form to the quadratic turning point form. So I have something prepared here that we can go through. So now the question wants us to convert the following from standard form. So that would be this form over here, to the turning point form, which is that form over there. So now the first thing to do would be to always factor out whatever is common. So the coefficient of x squared has to be 1. So you have to factor out whatever it is that needs factoring out. So again, the coefficient of x squared has to be 1. So we will start off by factoring out the 2. So that would be, if we had to have the 2 on the outside, we would have x squared minus 7x plus 10. So that's if we have the 2 on the outside. So we factored out the 2. So now to move forward, this would be very much the same as completing the square. To complete the square, we need to firstly make a perfect square. So remember that we make the perfect square by taking the coefficient of x. So that would be that number over there. So we will take it and we will half it. Then we will square it. And this would then give us a 49 divided by 4. So now once we've done that, we then need to add it and then subtract it. So we are effectively adding 0. So we can then have 2, which is still on the outside, x squared minus 7x. We will add the 49 divided by 4, then subtract it. So we haven't really tampered with the equation itself. We've only just added 0. Once we've done that, this over here becomes our perfect square, which we can factor. So now let's factor it out. So now this would then still be 2. This would be our perfect square. So that would be, so how you would write your perfect square is, you would have the x there. You would then take this number over here. So that would be the number, that number before you square it. So you would then take it with its sign. So that would be negative 7 divided by 2, then square. So you've effectively created a perfect square. You can then sort out these numbers over here. So now this would then just simplify to a negative 9 divided by 4. And you can then just close the bracket. So now moving forward, you can then just multiply out with the 2. So you can multiply in. So you would have a 2 bracket x minus 7, or rather x minus 7 divided by 2 squared. And then if you had to multiply the 2 with 9 divided by 4, you should get a negative 9 divided by 2. So now this in itself would have, you would have accomplished what you had set out to do, which is to convert from the standard form to the turning point form. So if you want, you can actually write out your turning points, TP, the turning point. You can then have it as 7 divided by 2, which is the x. So that would be the P, is to negative 9 divided by 2. So that would be the turning point that you would have, or rather that you can read off from the equation. So now, gents, that's what I wanted to share with you today. Please do go over the vid so that you may be able to attempt the work properly. A good day to all.